Hi guys, today let us study another numerical based on the boiler and enthalpy concept. Determine the density of 1 kg of steam initially at a pressure of 10 bar having a dryness fraction of 0.78. If 500 kilojoules of heat is added at constant pressure, determine the condition and internal energy for the final state of the steam. Take the specific heat of the superheated steam as 2.1 kilojoules per kg Kelvin. Now, in the question, it is given that the mass of steam is 1 kg, pressure is 10 bar, the dryness fraction is 0.78 and the specific heat to be 2.1 kilojoules per kg Kelvin. Now, from the steam tables, corresponding to the values of the pressure 10 bar, we have the values of the saturation temperature to be 179.9 degrees Celsius, HF to be 762.6 kilojoules per kg, HFG to be 2013.6 kilojoules per kg, Hg to be 2776.2 kilojoules per kg and Vg to be 0.19430 meter cube per kg. Now, initially the steam is wet. The formula for the density of the wet steam is given as 1 by the specific volume of the wet steam. The specific volume of wet steam is given as x into Vg. Hence, the density will be equal to 1 by x into Vg. Substituting the values, we have 1 divided by 0.78 into 0.1943. On solving this, we get the density of wet steam to be 6.6 kg per meter cube. Now, to find the enthalpy, we know that the enthalpy of wet steam is given as Hf plus XHFG. Substituting the values, we have 762.6 plus 0.78 into 2013.6. Hence, the value of the enthalpy of wet steam will be 2333.2 kilojoules per kg. Now, it is given that 500 kilojoules of heat is added to this steam. Hence, now the new value of the enthalpy, that is H1, is equal to the enthalpy of wet steam plus 500. Hence, H1 will be 2833.2 kilojoules per kg. The H1, as you can see now, is greater than the value of Hg. Hence, from this, we can come to know that the steam is superheated. Hence, the value of H1 will be nothing but Hsup, that is the enthalpy of the superheated steam. Now, to find the internal energy. The formula to find the internal energy of the superheated steam is nothing but Usup is equal to the enthalpy of superheated steam Hsup minus 100 into the pressure P into the specific volume of the superheated temperature, that is Vsup. Now, Vsup is given as the superheated temperature divided by the saturation temperature into Vg. Now, we don't know the value of the superheated temperature, but we know that the enthalpy of superheated temperature is given by Hg plus Cps into Tsup minus Tsat. Now, we know all the values other than Tsup. Hence, by substituting these values, we have 2833.2 is equal to 2776.2 plus 2.1 into Tsup minus 179.9. On solving this, we will get the value of the superheated temperature to be 207.04 degrees Celsius. Now, substituting this in this, we have the specific volume of the superheated temperature to be 480.04 divided by 452.9 into 0.1943. Hence, we get the value of Vsup to be 0.2059 meter cube per kg. Now, substituting this value in this equation, we have the internal energy of the superheated steam to be 2833.2 minus 100 into the pressure 10 into the superheated volume, that is 0.2059. On solving this, we get the value of the internal energy of the superheated steam to be 2627.3 kilojoules per kg. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.